Okay, well, good afternoon, everybody. Hopefully everybody can see the screen. And let me get this into presentation mode. There we go. All right. So today we want to look at just trying to find the value in cooling our milking herd, and appreciate the opportunity to share for a few minutes this afternoon. And as we think about the upcoming summer months, it's high time that we need to think about this, and just want to cover some things that I think are pretty important. So spent about 30 years now between the feed industry and the university. Spent a lot of time with cow cooling, as well as some nutrition and facility issues, and more recently have been working with some issues with robotic milking. And enjoying my time here at Kansas State, both as an extension professor as well as part of our teaching staff as well. As we think about the losses due to heat stress, Dr. St. Pierre many years ago put together this data, and depending on where we're at in the United States will impact how much potential milk loss we have and what the cost of that is. And the cost of milk production is just part of the equation. We also see some increased reproductive culling cost as a result of that, increased deaths in some instances as well. And there's a difference in the number of annual hours of heat stress as a percentage that we actually see depending on where we're at. And some areas of the United States are much more stressful. If you look at the data from Florida, for example, compared to Wisconsin. But the point is that most of the places in the United States do have heat stress. And heat stress, let's take it from a milk perspective. We can lose 10, 15, 20 pounds per cow per day. And these circles just emphasize where we see that loss in milk production during the year. And most of the time we see that during the summertime, but there are some effects that we'll talk about today that go beyond that. So what is its value? And as I get started today, I just thought that it's really important for us to address this, because we're looking at a situation where we're going to see probably significant increases in the value of raw milk as we move into the summertime. And I don't know if you're watching the projections or not, but we're at $20 milk now. We probably will move into that $24, $25 milk, and some people are talking maybe as high as $30 a hundredweight for milk. So if that is the case, and if you have even a 10-pound loss during the summer, and you can take your records and look to see what your losses are at, but if we have a $25 milk and you have a 10-pound loss, that's $2.50 a cow a year. Or excuse me, $2.50 a cow a day. So as we think about that, if we run up to $30, then that 10-pound loss would be $3 a cow a day. So, if you think about that, if you have 1,000 cows and your $20 milk, it's about $60,000 a month. If you have this summer, if you have $25 milk, that's about $75,000 a month on 1,000 cows. So yeah, part of this is feed costs. So let's just say half of that would be feed costs. So, you're looking at $30,000 if you're on the $20 milk a month that you could have an increased revenue. And I think you should stop and think about that. This summer is going to probably be different than many of the summers that we've seen before, in the fact that we may have some really high milk prices. And I know what you're concerned about. You're going to have high feed costs. You're going to have high cost of fuel. Fertilizer is going to be expensive. Yes, all of those costs add up, but you need to look at this equation from how am I going to increase milk income during the summer? So one of the ways you could do that would be to do a better job with cooling your cows so you don't lose as much milk over the summertime. So I'd encourage you to go back to your records and just look over the last 2 or 3 summers how much milk you've actually lost during the summertime, just simply due to heat stress. And in the lactating herd, that usually is a very significant figure if we look at that. Now, there's a couple other things to recognize as we get started here, is that there's some other losses here that are really significant, and that's the increase in days open. As you think about higher feed costs, I think you need to think about what is the value of another day open. And, you know, sometimes we use the figure of $3 or $3.50 for each additional day open that it cost us. Now, maybe with higher feed prices and everything else being higher, that's going to be $4 or $4.50 a day. So heat stress and the reduction on repro is going to be a huge consideration as we think about going through the summertime. You all are familiar with the temperature humidity index, and you know, we take the combination of temperature and humidity, and we come up with these various levels. And as we get more and more stress, we can actually get to the point where cows start to die because of heat stress. And unfortunately, once in a while, we see some temperatures and humidity, the combination of the two, that do lead to dead cows. But here's something that you might want to think about. When we look at these thresholds, you can measure breaths per minute. That's something you can easily do. You can do rectal temperatures. So as we hit that stress threshold, we're breathing about 60 breaths per minute, and the body temperatures are going to be 101.3 or just a little above. As we increase stress, we'll go to 75 breaths per minute. The cow's going to try to breathe faster to get rid of some excess heat in that regard. She'll probably reach a point where she can't expend all of the heat to the environment, so body temperature starts to rise. As we increase the stress level, those breaths go up to 85 breaths per minute. And the body temperature goes up when measured rectally. And then when we get to the severe situation, you're going to see breaths that are very, very quick, 120 to 140. They're actually very difficult to count when we're at these levels. And the body temperature is going to go up. And, you know, it's not uncommon to see rectal temperatures around 106, which, if we stay at this level for too long and we increase a bit further than that, that's generally when we're going to start to see deaths in the animal. So cows do exchange heat with the environment. And I just want to share that there's heat being produced by the cow. Basically, you have metabolic and digestive heat that's produced. We also have solar input, and that could be from exposure to sunlight. Temperature and humidity also are a factor. If the air temperature is above cow's body temperature, that's going to be a heat input as well. So the cow will use these various methods to try to exchange heat with the environment. But if she cannot exchange all the heat that she's producing as well as what she's being exposed to, we're going to have heat load. And when we start to have heat load, that's when we see those body temperature rise. So first thing, protect them from sunlight. And some research done many years ago, but it's still very valid. And it can show you that, you know, our heat input in full sun will be about 5,400 BTU per hour based on that research. So we need to have shade. Thing I want you to think about from this picture is that you can see the cow's shadow. So if you can see the cow's shadow, then that means she's actually being exposed to some heat stress. And we haven't blocked off all of the solar radiation. So you can see the solid roof next to her, part of her body is shade. It does not show any shade, but the part of her body out underneath that shade cloth, it's just not heavy enough, dark enough, if you will, to block out all the solar radiation. So she's still getting some of that. So as we construct barns, we just got to remember that in natural ventilated barns, we want to construct those east to west, and they're axis of their orientation. You do north and south, what you see there on the left, you can see the sun coming in the afternoon. It'll also come in the morning as well. So we do not do a very good job of protecting them from solar radiation. Now, you can put shade cloth on the side as this farmer has done, but that's going to cut down on the air moving through that barn. So even though we protect from solar radiation, we create another problem, and then we'll have to come in and put in extra fans for circulation. So just for a minute, if we're going to try to increase the amount of heat that she can exchange with the environment, how are we going to do that? And again, from this study, if the temperature is above 70 degrees, you can see that most of the heat loss is due to evaporative cooling from the outer body surface of the animal. And this is without applying additional water to the animal. This data is just how does she naturally lose body heat. And when we get above 70 degrees Fahrenheit, most of that is going to be from evaporative cooling. Some of it's also going to come from the respiratory tract. That is the reason why she increases her respiration rates so that she can exchange more heat from environment. Those non-evaporative methods like conduction, radiation, or convection, when we're in a heat stress situation, they really don't factor in much. We need to be thinking about how we increase the evaporative loss from the outer body surface. And that's exactly what we've worked with a lot here at K-State. And, these feed line soaking systems combined with the fans overhead to increase airflow. So we increase the evaporation rate of that water. That's a very, very effective way to cool cattle. And for many of our farms in kind of traditional natural ventilated barns, trying to accomplish this becomes easier. We've got better fans today, as well as better control systems that we can use. And some of our research that we've done here in previous years clearly shows that as you increase the frequency of wetting. So the numbers here would be how often the animals were received a soaking cycle. So the orange refers to a soaking cycle every 15 minutes. The 0 would refer to no soaking cycles at all, just fan, hot air blowing on hot cows, basically. And then the blue would represent soaking those animals once every 5 minutes with a fan or without a fan. So you can see the most effective way to cool animals that are already hot. These animals were hot when we started these treatments, and this is 5-minute period of time where we measured rectal temperature during that time. So as you can see, if we soak the animals once every 5 minutes and we have a fan blowing on them, this would have been roughly airspeed over these cows would have been about 8 miles an hour. So give you an idea, we can actually cool these animals down fairly quickly when they're already hot. We also looked at different air speeds, and you can see we do a more effective job of cooling cows at higher air speeds. So often when asked what kind of airspeed do we need over these cows, we'll tell you 6, 7, 8 miles an hour. In some cases, we even go a little bit higher than that. And again, this data was collected with soaking cycles. So the animals were exposed to the same soaking frequency once every 5 minutes, but then different air speeds above them. So as you have some airspeed, you get more heat loss from the animal. As you increase that, you will get more heat loss from those animals. So really, if you're in a conventional barn, you're trying to figure out, what can you do to the cows for the summertime heat stress, these feed line soakers actually work very well, and they're very effective. Got some challenges we'll talk about, but you really want to just wet the cow and dry the cow. And our design criteria that we generally use is each soaking cycle should be 0.03 gallons per square foot. And we usually figure about 8 square foot per animal, basically a 2 by 4 rectangle is what we're thinking. Now, how are you going to accomplish that? These control systems, this is probably the simplest one out there on the market. It's about $550. It has its own temperature probe. It will control at least 4 zones in a building, or 4 sections of your building. So you kind of have a standard 4-row freestall barn. You've got 4 different pins. You can have a solenoid in each pin, and this controller will take care of that. It's programmable. We can vary the shower time. We can vary the amount of drying time. And then this has a mode where it'll actually draw linear lines. So as temperature starts to rise, it'll start increasing the shower time or decreasing the drying time, or both, depending on how you set that system up. So it's very versatile. They're very durable. They're NEMA 4 enclosures, so they can be exposed to rainwater. And I'll be honest, I've got some of these out on farms that have been there for about 15 years and really haven't had much to do with them as far as servicing them. So they work very well. The other important part of this is just making sure we have a system that'll put water where it needs to be. And, from the spraying system part of agriculture, that's where we get this. These are T-jet nozzles. There's other manufacturers as well that you can get very similar type material that works very well. The important thing about this, though, is the check valve. All of our soaker lines are going to be sloped generally with that feed line, so that if we don't have a check valve at each nozzle, the system's going to drain out in between soaking cycles. Then it's going to we're going to have to run it longer to get pressure built up over the whole line, so we get an even distribution of the water. So these check valves are very, very important in determining that we get water at each nozzle as soon as the system kicks on. And generally, if we have everything sized right and spaced right, we should only have to run these soakers probably somewhere between 15 and 30 seconds to get an effective soaking cycle. As soon as the water starts to run off the animal, we can shut the system off. Generally, we space these on about 6 foot. Is generally how you get the best pattern. So what are some of the issues? Well, having enough water pressure as well as supply can sometimes be an issue on some of our farms. And the other thing you have to remember is that if we operate these in the normal fashion and do not try to emphasize when cows are actually at the feed line, probably about 75% of the water the system puts out is going to end up in the lagoon. So we need to think about when the feed line is going to be used. Animals only spend maybe 5-6 hours a day at the feed line. We know that from behavior data, and they're going to spend most of their time laying down, hopefully. So as a result of that, we need to think about how we do that. So one solution would be to use a system that would allow the soaking system only to be on when you were feeding or when you were pushing up. Some other systems would look at some sort of sensing system to detect cows, maybe like a garage door opener device. Those will work, but you do have to keep them clean. And with flies in the summertime, that can be an issue. The goal is really to reduce water that we put out through that system. And if you use some sort of limited soaking periods during the day related to when cows are actually at the feed line, again, primarily when we're feeding, when we push up right after milking, we can probably reduce water demand on that system by about 50%. Probably one of the most effective ways to do that is just a simple timer. This is a manual. You could use an electronic, you could use a computer program to run that too. So you just set up maybe 6, 8, 10 different times during the day when you know animals are going to be at the feed line. And in fact, in doing that, you may actually encourage them to come to the feed line just to get soaked down so that they go back and lay down. So as we look at where we need to think about these fans and soaker systems for the lactating cows, really when you're in natural ventilation barns, cross-ventilated and tunnel ventilated barns, they can also be helpful. And in many regions, we do recommend that you do that in addition to the airflow that you're creating with the exit fans. Smaller farms, obviously, this might be a better application where we just maybe don't have the resources and the investment per cow to do something else might be fairly prohibitive. Holding pens are another excellent place. We can use fans and soaker systems, and actually that should probably be the place where we start. You know, as I look at the different options out there, this is probably the cheapest, most cost-effective way to cool cows, unless you're in larger facilities, and we'll talk about that here in just a minute. But the thing you have to remember, you got to manage the water. And if we incorporate some of these timing systems to only have water there when cows are actually there, that probably is the best way to do that. So as you think about these fans, fan design has changed greatly. And again, we need airflow over the feed line, particularly if we're having soaking systems there, as well as over the beds. So we sometimes use a combination of fan designs to do that in naturally ventilated barns. Sometimes, depending on the size of fans, we can use single row of fans over the stalls, and those will deliver fairly adequate airflow to the feed line. However, it's probably not going to be quite as fast of airflow as if we had fans dedicated just to the feed line. But in some environments, it's a way to control the cost of fans, as well as provide adequate airflow over that feed line. When I started out 23 years ago working with cow cooling, and all we had were basket fans, and we tended to mount those fairly close together. And a lot of times we ended up with an airflow that looked like this. It was pretty directed, didn't cover a very wide area. One of the big advantages of the panel fans, as well as the louver type fans, is we just really spread that air out. We can mount fans further apart, maybe 50, sometimes maybe up to 60 feet apart. We just cover a larger area. So some of these fans, it's very possible that we can be mounted over the stall, but then we can be throwing significant airflow over to the feed line, and that may be adequate to evaporate water. Now, in very serious, areas where we have a lot of heat stress, where it's extremely warm, you think about Texas, this may not be quite enough airflow to accomplish what you need to do. However, if you're maybe in Wisconsin or in some of the northern environments where we don't have as severe of heat stress, this may be an option for you to effectively cool cows without investing in quite as many fans. Now, the other thing you need to think about, depending on how old the fans are in your barn, you might might be to the point where you actually need to refan the barn. The equipment you're currently using is wore out, and you might want to check with your electric cooperative. There may be some special rates that you could get if you install fans that are more energy efficient. So it varies state to state, and even within states, it'll vary depending on who your electrical supplier is. So you might want to think about that as an opportunity to reduce your cost of electricity, but also get some help, hopefully, on the installation of newer fans. Some things that have come along with fans, again, a lot of design changes. We're more efficient today. A lot of the fans today are 25–30% more efficient, just the motors, than some fans that motors we had 10 years ago. So we expend fewer watts per CFM move. So lots of new designs out there. Many of these are on VFDs, or variable speed drives. Very, very important, because with VFDs, a lot of times we can turn those motors a little bit slower, run them at 80% or so of total full load capacity. They'll produce less heat. They'll last a lot longer if we can do that. And we also get an increase in the number of CFMs moved per watt of energy. And the other thing that we can do is we can spread that airflow out over the barn easier because we're operating a few more fans. That's okay, they're more efficient. So total electric cost may actually be less than it would be if you were just running a couple of those fans at high speed. So you might want to think about that if you're going in and replacing fans, that maybe some of the new fans you bring in, even though you have single speed fans, are basically on-off fans on some of the your air distribution system, you can have some variable speeds you could run at other times of the year. The other thing is controls have changed tremendously. We now have controls that are fairly sophisticated and can do many different functions and run many different fans, some at different speeds than others. So there are some significant changes there. Many of these are centralized. So if you want to turn fans on or off, you just go one place to do it. Many of these also have application apps basically that you can have on your phone. So you could be halfway across the country and still operate the fans on your dairy farm. So really some neat things that we have there. Now, if you get by the naturally ventilated barns, what are you going to do? Well, you know, a lot of times when we start talking these large tunnel ventilated barns or cross-ventilated barns, we start looking at evaporative cooling. And one of the first ways that we accomplished this was the evaporative pads. And those are still used. There are some issues with those. And for those of you that maybe have had them, you understand some of those issues, but there are also some benefits to those. So when you think about the cooling pan or the cooling pads, you don't really have a lot of controls generally. And there's a reason for that, is because the only water we can get into the air is what will actually evaporate as it goes through that pad. So they're pretty foolproof to operate. We just have to decide when to turn them on, and if we're going to have a drying cycle sometime during the day, when that's going to be. A lot of times we don't run these 24/7. We probably should be turning them off for 2-3 hours at night. Usually a lot of times, sometime during the nighttime hours where we have higher relative humidity, and we're not actually going to be evaporating much water in many environments due to the increase in relative humidity at night. They do require a lot of maintenance, and they do slow down the airspeed. So generally these pads work best if we keep the airspeed under 400 feet per minute. We start to get above that, we start to pull water off the pad and actually put it on the floor. So you get a wet area in front of those pads when that happens. To help with the maintenance on the pads, cut down on washing them, there are some treatments that you can add to your water. So water quality becomes very important with these systems, and making sure that we're not getting mineral buildup inside the pad. And the pads are going to have to be replaced. So that's a huge maintenance cost. Probably every 6 to 7 years, these pads will have to be replaced. If you do not treat your water and you have significant hardness to that water, you will accumulate mineral deposits on those fans fairly quickly, and you probably will not get 7 years of life out of them. They'll start to become plugged, less efficient at evaporating water. They're great. They can be used in this instance if you have a area that where you have organic bedding. This is from our K-State dairy unit. This is how we cool our transition cows. So we just built a little lean-to onto the side of the shed, and we've got fans on the inside of the barn blowing air onto the cows. It's pulling that air through the evaporative pad. So we can effectively do this, pretty minimal cost actually, and allows us to cool animals that are on organic bedding very well. This is just a couple of pictures of the construction right after the fans were installed, and then building the frame, and then the finished product. So works very well, an efficient way to do that. And is this graph depicts during the afternoon hours, we significantly drop air temperature that those cows are experiencing. So drop it down to about 80 degrees versus outside. It was about 93 when this data was collected. So it really takes that edge off the afternoon hours and has worked very well for us over a period of years. Now, here's the issue with all types of evaporative cooling. It's really relative humidity. When relative humidity is low, less than 40%, we can get some very, very significant temperature drops, as this graph depicts. However, as relative humidity rises, it becomes more difficult to really effectively use evaporative cooling. And it doesn't make any difference whether it's a cool cell type situation or whether it's some sort of high pressure mist system. We just can't evaporate more water into the air. And as the temperature decreases, we can actually evaporate less water. So, you know, at 50% relative humidity, we can influence and change the temperature with evaporative cooling. But when you start to get to 70% or 80% relative humidity, as you can see in this graph, we really don't get much benefit to the evaporative cooling. And when we try to continue to increase the amount of water we're putting into the air, you're just going to end up with a wet barn. And that's been some of the challenges that we've run into with many systems as we go to these fogging systems, because fogging systems, unless they have excellent controls, they just push out water into the air. If that water evaporates, it's great. If it doesn't evaporate, it's going to condense on metal, it's going to condense on bedding, and in some cases even condense on cows. So having the control of these systems is very, very important. We've made some strides in that. We continue to try to do better. But there are some challenges to it. So if you think about a fogging system, this should be fairly simple, right? So because of the fans that you're using, particularly if you're in a tunnel ventilated or cross ventilated situation, you know how much air is entering and exiting the system, or at least you should know. You also know the temperature and relative humidity of that air that's coming into the barn. Based on that, the volume of air coming in, the temperature and relative humidity, you can predict how much water you need to evaporate or can evaporate. And part of that is controlled by the speed of evaporation. So as we get lower relative humidity, as we get higher temperatures, that water is going to evaporate quicker. So they're complicated calculations. They're all dependent on one thing, in general, and that's the humidity sensors. And those could be both for ambient or the incoming air, as well as in the barn, sensors to determine how much relative humidity, how much we've raised it through the evaporation of water. Because we're always going to raise the relative humidity when we evaporate water, just the way it works. These sensors, many times, we have issues, and they require maintenance. And if you don't do the maintenance, the system is not going to work correctly. So another problem that you have, once you get past this, these nozzles work best at a set pressure. So if you lower the pressure, in other words, you try to lower the amount of water that's going to these nozzles, you just get larger droplets. Well, when you get larger droplets, it doesn't evaporate as quick, and we're more likely to get wet condensing situations. So if you're going to vary the amount of water that you put through these systems, you have to have multiple systems. So you might have 3 or 4 different lines down through your barn that come on in stages as we need more water evaporated in the air, as the air temperature goes up, as relative humidity goes down outside, we can evaporate more water. So we bring on another set of lines. Well, this is a lot of extra equipment, and this equipment is not cheap. It's also not necessarily easy to maintain. So we've made a complicated system. So the control system for these types of installations, you have to control the fans, you have to control the amount of water that you're trying to put into the air. And you have to do that relative to ambient temperature and relative humidity, as well as the temperature and humidity coming in or within the barn as we start to evaporate water and cool it. So you have location issues as well. Do you want all these lines on the inlet? Do you want them in multiple locations in the barn? And I think in many cases, we're looking at maybe a couple of stages on the inlet now, and then as we move across the barn, maybe another stage or two. That way we do not concentrate all the misting in one particular area. We spread it out, allow that water to evaporate as it comes into the inlet, and then just simply add a little bit more to it as it goes through the barn, and hopefully also picks up heat. So it should be able to evaporate a little bit more water as we get into there. So again, these fans have been improved in efficiency quite a bit. Air distribution, and that's kind of something I want to touch on here just a little bit. One of the advantages of the louvers, or even the circular fans with changes in blade design, we can actually direct the airflow down on the cows where it's actually needed. And that air distribution down at the cow level is really important. So now, rather than just pulling air through the building, we look at trying to get it actually down on the cow. So as you think about a tunnel ventilated or cross ventilated barn, we're going to have exit air that we're going to need to deal with, but we really need air down on the cows. So as you look at different designs, a lot of times we've utilized baffles in the past to try to get air down on the cows, and those have to be spaced in the right places across the barn. They do create some increase in static pressure coming across the barn, but they are a way to get the air down on the cows. And, you know, we can go with these low profile barns, and we save a lot of lost air that gets lost up essentially in that attic space by being able to lower that roof height and keep that air down closer to the cows. So, you know, this is very common. Baffles need to be placed across either tunnel ventilated or cross ventilated barns that are going to keep that air down on the cows where it's actually going to be effective in cooling the cows. So we have to have these baffles, and that is one approach that we've used. It does work. I would encourage, you know, when we're doing this, we think about automated controls as opposed to manual controls. This is a barn setup where somebody has to go through and plug the fans in as they need more fans. Probably not going to happen in most barns. So another advantage would be variable speed fans. So the fans in this picture are single speed, they're either on or off. Variable speed drives are really, really important in trying to increase the efficiency of electrical use, but also giving us greater control over how many fans we can run. So VFDs give us some significant advantage in that we have a range of ventilation rates that we can use. It helps us with wintertime ventilation. We also get more uniform air movement because we're going to probably operate more fans, but at lower speeds. Rather than just having a few fans run at maximum speed, we're going to open up and we're going to run multiple fans, but we're going to lower the rate at which they turn. We may only run maybe 20-25% of total potential capacity as we need lower amounts of air moved when the temperatures are cooler, but then as it warms up, those will gradually increase. And as a result of that, we increase our energy efficiency as well. So getting the air where it's needed is very, very important. And again, louvered fans are just one way of doing that. So really, as you think about barn design today, we're looking at entrance fans where we push air in. We're looking at exit fans that move the air out. And then to try to get the effective cooling where the cow actually lives, to get it down on the beds, we we might be looking at using either large panel fans or the louvered type fans. And it looks a little bit like this, where you have an air intake, a set of air intake fans, but then you also have fans that are going to direct air down into the cow beds. And that'll also, you know, if you're thinking about organic bedding, if you're thinking about trying to reuse manure solids, make sure that you think about how you're going to move air down onto the surface that the cow is actually laying on. That will increase the likelihood that you'll be able to dry those. A lot of times those solids are put in there, they're semi-moist, so we still need to dry them out down on the bed. So increasing airflow into the stall is one way that we can do that. So as you look at where we're doing essentially this application of powering the inlet, if you would, with fans, we're doing it in cow housing. It's also very effective in the milking parlor as well as the holding pen. So see a lot of designs going up on farms where we're doing it in those other two places. So as we think about the summer, and hopefully this summer you don't see cows like this on your farm, you need to think about the heat accumulation that your animals are going to be exposed to. We can have periods of heat exchange, and we can do that effective with the soaking and fan systems if we're in a conventional barn. If you're in tunnel ventilated or cross ventilated barns, you're still going to have periods of heat exchange and times during the day when we can exchange more heat than at others. And you got to keep in mind that if she can't exchange all of that heat in a day, her temperature is just going to build. And so if we can't really get our cows cooled off in the evening hours so that they can face another day of heat stress, we've got a pretty severe problem on our farm. You're going to have to work with what you have. I encourage you to look at steady improvement. You know, think about where we're headed with economics for this summer and the importance of achieving higher levels of summertime milk production. For those of you that are a little bit further north, the reproduction thing becomes an important thing too, because you can gain a lot in reproductive efficiency generally in our more northern environments if you do a better job of controlling heat stress. And it's kind of my final point, that we got to keep in mind that our losses are more than just milk production. The impact on days open, because we do not get cows bred on time during the summertime, is a significant drag on our efficiency for the rest of the year, and may actually lead to some additional culling of our animals. So with that, just thank you for your attention today, and just want to thank my colleague, Dr. Herner, for our many years of association and working together as we try to help solve cooling issues on dairy farms. And with that, I will stop my share, and I think we have some time for questions.
Yes, we've had a few come in, and again, if anyone has any questions, please type them into the Q&A panel. So our first question is, if water savings wasn't an issue, would you soak more often to prevent an animal from going into heat stress? And would there be any point to linear adjustment from 5 to 10 minutes of off time?
So as temperature rises, so we typically set these systems up so that, let's say at 70 degrees Fahrenheit, the animals are soaked one cycle every 15 minutes. As the temperature rises, depending on the controller, we might go all the way up to, if we just have essentially 2 stages to set. So maybe at 70 degrees, we soak once every 15 minutes, and that soaking cycle would only be until water starts to run off the cow. Once the water starts running off the cow's back, there's probably not a lot of advantage to continuing to apply the water. There is a temperature difference between the water and the cow's body temperature. So you're doing some cooling by applying that additional water, but you would get more benefit if you could dry or evaporate. For every pound of water that we can evaporate off the cow, she'll actually have to expend about a 1,000 BTU of energy. So evaporating pounds of water will be better than simply just continuing to soak that animal. So we start at 70 degrees with one cycle every 15 minutes, and then at our high point, we maybe hit 90 or 95 degrees. And at that point, we're soaking those animals about once every 5 minutes. Really going to depend on the environment you're in and how much water you can evaporate. If you're not getting significant evaporation in between the soaking cycles, you probably need to decrease the or increase the time between soaking cycles so that we actually get some evaporation.
Thank you. So is fogging worth it when you can only use it for a limited time? Or would you recommend selecting a soaker system that can be used all the time when it is hot outside?
I think that's a great question. It's a kind of a huge debate. I know years ago we did some work in Florida in a high humidity environment, and they actually had a fogging system, and we came in and installed a soaker system in addition to that. So they had fogging to drop the temperature as well as soaking system to increase the direct heat loss off the cattle through the evaporation in water. We've also done the same sort of thing in Thailand, again, in a high humidity environment. So usually my answer to this is I got to look at, so what is the ambient temperature? Is the ambient temperature going to be above the cow's body temperature for a significant period in the day? And if that's the case, then fogging systems, as long as we have capacity to evaporate the water, will lower that temperature that the animal's exposed to. And that can be pretty important for us to do. However, there are other times during the day where we have high enough relative humidity that the fogging system is not going to be effective, or the cool cell, because we can't evaporate more water. So at that point, then it's time to look at the feed line soaking system to try to give some relief and get, because her heat off of her body will evaporate some of that water that we put on her back. We may not be able to have as many soaking cycles or soaker as often, but we will get some cooling from that evaporation of the water from her body heat.
Thank you. So with a limited budget, what would be your first, or what would you recommend for first investment of cow cooling equipment?
So the first thing would be shade, protection from solar radiation. The second thing would be in the milking parlor holding pen, and that's going to be soakers and fans. That seems to be, and again, one of the things you need to think about there is that we need fresh air coming in. And that's the reason why we're starting to see quite a few installations where we use fans to actually force outside air into the milking parlor holding pen. And we may even see those techniques used on the milking parlor itself. The important thing there is that we're packing cows in very close in our holding pens. And if we do not do an effective job of cooling them there, they'll actually get heat buildup during the time they're at the milking parlor. And we need to keep in mind that, there's some really good research out of Florida as well as other places that shows that when the cow's body temperature rises and we get above 102.5, we start having significant early embryonic loss. And that's the reason why we end up with, so many cows that simply do not settle during the summertime, is because her body temperature has exceeded kind of a set point that will actually make it difficult for her to maintain that pregnancy. So cooling in the holding pen would be very, very important. And then third place would be how are we going to cool in the cow housing area? So shade, holding pen, and then how are we going to cool in the cow housing area?
Thank you. And a little bit of a follow-up. So if we are soaking in the holding area and that's taking place right before milking, is there risk from the water to transmit dirt bacteria to the udder, potentially causing some contamination?
Excellent question. And I actually get that question quite a bit. You know, most cows, if you actually look at them, the udder is tucked under the animal. So if we're operating our soaking systems in the holding pen correctly, there may be some excess water that runs off her side, but that water is going to run off the side and hit the floor. It's actually not going to get to the udder. Her body is kind of like an umbrella, if you will, for the udder. Now, some people have used in the holding pen, and I mean, I've done this in situations where I didn't have anything else. They'll use like garden sprinklers or something like that, where we put a lot of water on. Well, in those cases, we could get some water down onto the udder, as well as possibly even onto the teats. Depending on how dirty the animals are, essentially, will determine how much bacteria we might put down to the teat end. The other thing we sometimes do is we put soaking systems into the holding pen is we might leave the front, say 10 or 15 feet. It depends on how big the holding pen is, how many animals we're trying to load out of there into the parlor at a time, so that they have some dry time before they actually get to the milking parlor. So we soak them more in the back of the holding pen, middle of the holding pen, but when they get to the final section of the holding pen, we actually do not have soaker lines there. We just have fans.
And then one other question about cooling in that holding pen. If there is a dairy that is utilizing grazing, so cows are not housed in a barn, is there real benefit from cooling the waiting area and the milking parlor only?
Well, interesting question. Actually, some of the original research done by Dennis Armstrong in Arizona, those were in dry lot dairies, and they would bring the animals to the holding pen and cool them in the holding pen, just with fans and soakers. And they showed that if you gave them 3 cooling cycles a day, they lowered body temperature during those cooling cycles, and they increased milk production by about 3 to 4 pounds per day compared to those cows that did not get those cooling events during the day. So I would say, based on that, yes, there is value to doing that even in a grazing situation, particularly depending on what time of the day you're doing your milkings. A lot of times, grazing situations, we're only milking twice a day, depending on the temperature in the morning. May or may not be a great advantage then, but depending on when you're doing your afternoon, evening milking, could be at the hottest time of the day. So definite advantage to doing it then.
Thank you. So this is regionally dependent, but generally speaking, if designing a multiple stage high pressure fog system, how many steps would you recommend, and at what temperature or humidity would each stage turn on?
Excellent question. I've seen different things tried. I've seen 2-stage systems tried, and depending on kind of design and how much total water we're trying to pump out, they usually don't work very well. I've seen 3-stage systems tried. Again, challenges into matching the volume of water that we're needing to deliver. And then I've seen, 4 stages. So You know, right now I'm kind of in the camp. We're probably looking in a lot of our environments to have really good coverage and to avoid excess water in the barn. We're probably looking at 4 to 5 different stages in order to be able to ramp up and down. So the question about what temperature do you turn those on, it's really going to be based on relative humidity as well. Generally, we probably, when the air temperature hits 65 to 70 degrees, if we have the capacity, in other words, a low enough relative humidity to start evaporating a little bit of water to cool that air, that would be a huge advantage. So in some environments we can do that, some we can't. Sometimes at 70 degrees or even 75 degrees, you're going to have so much relative humidity in the air that you really can't get any more water to evaporate. So if you spray it out of a fogging system, you're just going to end up with a wet barn. So
thank you. And I think we have time for
a complicated question, and it's dependent on relative humidity, air temperature, and also the volume of air that we're bringing in.
All right, so we just have one more question. Do you see an advantage of positive pressure systems in dairy barns regarding low electricity usage per cow, and that every cubicle of air transported is actually fresh air?
Yes, I do. I wish we had better research data that we could share as to how important that is. But you know, a lot of our barns, we blow a lot of air around the barn, but we don't get enough fresh air into the barn. And so these systems that actually force fresh air into the barn are very, very valuable to us. And, you know, working with the tunnel ventilated and cross ventilated barns, you know, a lot of times we've found that particularly in tunnel ventilated barns that are longer, we've got to open up allow some air to come into the barn other than just at the far end of the barn. And we allow some additional fresh air to come in, we actually get a better distribution of air throughout the barn, as well as less odor and issues in the barn.
Wonderful. Well, thank you so much, Dr. Brouk. We truly appreciate your time today. And I think with that, we will wrap up the webinar. So thank you again to everyone who was able to attend. We would like to invite you to our next webinar, which is on Friday, April 8th. It will be integrating and optimizing data streams to drive an animal-centered environment. So we hope you're able to join us. So thank you again, everyone, and we hope you have a wonderful weekend.